bring in the central processing unit. The CPU is the brains of the computer. Let's also bring in memory, the RAM. This is where the CPU accesses stored information it needs. Now the CPU also has built-in memory. This is called a cache. The cache is considerably smaller than the RAM, with sizes ranging in the order of 32 kilobytes to 8 megabytes. The purpose of the cache is to give the CPU the information it needs immediately. The CPU and RAM are separate objects, so when the CPU needs information, it takes time, albeit a very small amount of time, to read the data from the memory. This time can add considerable delay to computer operation. With the cache being right on the CPU reduces its time to almost nothing. The reason why you don't need much cache storage is because it just needs to store little bits of important information that the CPU will need to use soon, or has been using a lot of recently. There are various methods implemented to determine what goes onto the cache, what should be kept on the cache, and when it should be written back onto the RAM. In a typical CPU, there are various levels of cache, each with different read and write times and sizes. For the sake of simplicity, we'll assume a single cache for our CPU. So now, with the basic components out of the way, let's get into how the computer operates. When a CPU executes an instruction, there are 5 basic steps that need to be completed. Fetch, get the instruction from the memory and store in the cache in some cases. Decode, get the appropriate variables needed for the execution of the instruction. Execute, compute the result of the instruction. Memory, for instructions that require memory read-write operation to be done. Write back, write the results of the instruction back into memory. Nearly